Hi, welcome back to Mr. Slover's Math. Today we're going to focus on greatest common factor, and we're going to factor that out of an expression. So remember, an expression is something without an equal sign. So that's what we're focusing on. The warm-up is just getting us ready for factoring. Right? So we'll list our factors, find the greatest common factor. We get 4x squared. What's the GCF? Remember, that's your greatest common factor. So just another example. This time they're just numbers. We get 12. And then number 3 is asking you to simplify the following. So I'm distributing the 4x, and I end up with 12x squared minus 40x. Now you may be thinking, Mr. Slover, this question 3 on the warm-up doesn't really relate to greatest common factor. But it does. What I circled is the end result after the distribution. What we're doing today is the inverse of distribution. Just like every operation has an inverse, addition, there's subtraction, multiplication, there's division, squaring, there's square rooting. For distributing, there's factoring, and that's what we're doing today. We're going to start with this 12x squared minus 40x, and end with 4x times the quantity 3x minus 10. That's our goal. In order to do that, we've got some steps for success. So our directions say factor the following expression. Step 1, you're going to look for the largest factor from your factor chart. You're going to divide each term by your greatest common factor. And step 3, you're going to write what's left after you divided in the parentheses. I know that sounded like a lot, so let's go through example A. 14x plus 24. Your greatest common factor is 2. So I have a 2 on the outside of my parentheses. I am going to divide each term by my greatest common factor. So I'm going to divide by 2. 14x divided by 2 is 7x. 24 divided by 2 is 12. After you divide, that's what goes inside your parentheses. So that's what this green note is. For any of these problems, you have the GCF on the outside, and on the inside, you have what's left after you divide by your GCF. So my answer is 2 times the quantity 7x plus 12. That's me factoring this expression. Letter B, same idea. First, find the greatest common factor. In this case, it's 15. So I take out a 15. So that's on the outside of my parentheses. I divide each term by 15. 15y divided by 15 is y. Or if you wrote 1y, that's okay. 30 divided by 15 is 2. So what's on the outside is my greatest common factor. What's on the inside of my parentheses is what's left after I divide by the greatest common factor. Letter C, list my factors. My greatest common factor is 50. So I divide each by 50, and I end up with 50 times the quantity 2 minus x. I can do the same thing for letter D and letter E. I want to draw your attention, though, to letter F. Your greatest common factor is 12. So if I take out a 12, that means I divide each term by 12. Well, 12d divided by 12 is 1d. 12 divided by 12 is 1. Many students like to say that it's gone. It's not, right? As I just said, 12 divided by 12 is 1. That 1 still has to be there. Okay, and I made a note in red. It says I started with 2 terms. Up here, I should end with 2 terms inside of my parentheses. Okay, so make sure, even if you take out a 12, you take out the greatest common factor, and you do 12 divided by 12, you still have to write that that equals 1, or that simplifies to 1. Otherwise, you're not going to have the right answer. Okay, because if I just had 12 times d, that's not what I started with up here. I started with 12d minus 12. So example 2 is the same thing, except now I'm adding in variables with my greatest common factor. So my greatest common factor, I'm going to break it into two pieces just like I did yesterday. Find the greatest common factor for the coefficient, and then find the greatest common factor for the variable. And once again, that's always if there is one. There's not always going to be a greatest common factor, and there's not always going to be a greatest common factor that is both the number and variable combination. It just depends on the problem that I give you. So number-wise, for the coefficients, I could take out a 5. For the variables, they both have the letter x, and I take my lowest power. That's what I wrote in green. I take my lowest power. So I'm going to divide each term by 5x squared. And over here, I have the note. I'm going to subtract my powers, and I'm going to divide the coefficients. So 45 divided by 5 is 9. X cubed divided by x squared. I subtract my powers, and that actually should say 9x to the first, not 9x cubed. That was a mistake on my part. So that should say 9x to the first power. And then over here, I do 5x squared divided by 5x squared. Well, 5 divided by 5 is 1. My powers are 2 minus 2, so if I subtract them, I get 0. And you did learn that anything to the 0 power is 1. That's why I still have a 1 in my answer. So my answer, here's what I factored out, 5x squared, and here's what's left over, 9x plus 1. Remember, that should be 9x. Mr. Slover made a goof. Letter B. My greatest common factor for the coefficients is 4. They both have the same letter, so I take out the lowest power, which is c squared. So my greatest common factor is 4c squared. So then I divide each term by that. So divide each term, and I end up with my answer. Now notice this ended with a positive 1 and this ended with a negative 1. Okay, so make sure I started with 2 terms, I end with 2 terms. Start with 2 terms, end with 2 terms. Please make sure you do that. The rest of them are just more examples. If I look at letter F, 2b minus 12y. If I look at the coefficients, 2 and 12, my greatest common factor is a 2. But my letters, my variables, are not the same, so I cannot factor those out. So if I divide each term by 2, I end up with b minus 6y. And then the last example, example 3, says factor the following expressions. If I look at 4 and the 3, my greatest common factor is a 1. They both don't have an x. So if my greatest common factor is a 1, you are going to write prime. Same thing on letter B. If I look at 199, my greatest common factor for the coefficients is 1. My variables are different, so there's nothing I can do. They don't have anything in common. So once again, since my greatest common factor is 1, I'm going to write prime. Same thing with C. So today we focus on factoring out a greatest common factor for an expression. You have your greatest common factor on the outside of your parentheses, and then what's left after you divide by the greatest common factor is inside of your parentheses. If you have questions, make sure you ask. Otherwise, thanks for stopping in. Till next time.